Okay, welcome everyone. I'm Michael Trimarchi from Amarula Solutions. I'm here to present a user experience and experience of our company that we spent together 7 years with a customer, mostly on the medical, the field is medical devices. We try to move their way to works from, let's say, legacy components to upstream components. And I think that it was quite successful. Of course, require 7 years is not really. It's a very small window. Yeah. So. Okay. That I seen one talk a long time ago that started just with one slide. It's about just questions. I mean, everyone in this room mostly has deal with the companies or with the products that was having a lot of legacy components. Is quite, just you question if you want to start that project or not. You have a lot of comments to the companies that you would like to say, no, keep it, I will not get in these projects. But at that time I said, okay, let's see what the problem is, if we can help really and leverage the way it works, because most of the time is really to change the paradigm of the companies and to say, okay, you work that way, try to work this way, try to adopt the best practice, try to see what the others are doing and what is public available, so you can learn from others and to make your working flow much better. And much better does not mean that their products in the field are not working. It means that it costs less times, it costs less stress for the developers and for the QA that need to test. So, as I said, I coming with these companies. It's a consultancy company, every other companies. I don't want to spend too much time on that one, but we work basically in all the stacks on all design of products. So from user spaces, graphical application to kernel, bootloader, and so on. Yeah, for me, we spend some time with about me. I'm just a software developer coming, starting, I think, in with Linux in 2000s professionally, but starting in 1995. My thesis was implemented virtual memory compress in FreeBSD. So I just started with operating system quite early. And then I just spent my times to small contribution to a lot of open source. Recently, I just like to spend times on Jenkins plugins because it's just fun. And even I don't like Java, but it's something that it's open source. It's something that I need in a company. I said, okay, just pick it up and see what I can fix when something gets wrong. Yes. So how usually we start a project with some company? For me, it was just I get contact. Okay, don't contact me during the weekend, but I get contact for just USB pen drive insertion extraction problems. They was running downstream U-boot, downstream kernel, and I need to fix this one. They said, I was traveling a lot at that time. He said, okay, you are able to fix? Yes, when I have times. And then they give me a deadline, like we need in 2 weeks. I said, okay, let's start properly. So what I do is just forget about their code. I said, okay, let's support the latest U-boot. Let's support the latest kernel that I have in mind, and let's try it. So then I just go. It was faster that to make it workings and to get in a use case that I can able figure out. Because when you work with very old kernel and downstream, he said, okay, there is a lot of things that maybe are not well documented. Let's go to upstream. And then I try to find the reason why I need to bisect between the bootloader to the Linux kernel. And then I said, okay, let's figure out. But the problem was in the bootloader, incredible. And it was upstreams and the legacy U-boot at that time. And then when I fixed the legacy bootloader and I uploaded the patches in upstream for U-boot, I said, okay, what I said, I said, this is strange. It was faster to have it running on some new U-boot Linux kernel, and they're struggling to continue to work on that version that they get from the vendor. I said, okay, let's propose them to migrate their process to some more upstream, so we can figure out how it works. So yes, so from that time, it's past 7 years. So let's try to figure out what we are talking about. So basically, I talk about the story, what was the transition to come to there, where we are now, and what we learned from this, and let's figure out together what can be the features of this experience, and what bring to us, what bring to the company, and what brings small things to the open source community, and why it's so nice that I would like that this experience can be replicated by other small companies, other freelancers that already do, but it's more involve more people in this process, and let's think that it's even fun. Yeah. So what is the problem? So most companies, start from they have starting point. I don't see that is good as bad. I think that recently a lot of vendors try to work much more upstream. I think TI, for instance, yes, and ST and NSP. So they are much more close. But yeah, of course, when you need to find a balance between what the vendor proposes and what you already have upstreams. So my idea is that to try to start as much as you can from upstream components, because working from vendor in the long term, it will be really counterproductive for your products and really difficult to maintain. Because the process that they maintain their BSP, at some point they stop to maintain some versions and they just cut the new versions with all, the stress to that I don't have it, start to think about what I can take from myself and so on. If you have right, like clean setups in the beginning, one of the most important part here is really to start properly. I think that is one of the main points when you start a project, is to think about all the parts that you are needed during the product lifetime. Not just to say I start with this one, then I change that one. Just figure out in the beginning. It was not in this case. We will see that in this case was a bit more complicated. But yes, for the new product that I design, and not always successful, I mean successful because in the end, maybe the company get for downstream kernel anyway. But I try to think about what will be the future from now to the next months and for the product's lifetime, So we try to understand what is the challenges to maintenance and embedded products. Yeah, I'm in the medical field, so figure out that I have some constraints. I need to be sure that the information that I give to third party are good enough that you can sell that devices. So there are processes that you need to understand how much you are close to, let's say, a product that it's not sellable just as a company, but is sellable through other parties, that you need to give them all the documentation needed for this product to be on the market. So what I try to do is, I said, okay, let's completely embrace open source philosophy. Let's try to get rid of all, the vendor part and see how we can increase it. So I work mostly in this project together with other parts of the teams on Linux, U-boot, continuous integration, Buildroot, that was part of the, the knowledge of the company that we are working with. So what I said in the beginning is not most of the time is not only technical. So yes, it is, but for me was really very struggling in the beginning to let understand that this transition is going to be benefit for them. Yeah, most of the companies, so they ask always, yes, but what is the benefits in terms of money? How do you calculate it? I said, okay, it's not possible. I can say that if we arrange the flow as it should in the company, then we can figure out later what can be the benefits. I cannot calculate in this. So So that, yeah, so back in 2018 was around 50,000 devices, all based on kind of embedded Linux, mostly based on Buildroot, but variants on Buildroot or yeah, several releases or several versions of Buildroot with some even pre-built binaries because they received the BSP from another vendors. So it was the vendor of the vendor, and then a lot of different architectures and different serial version of U-boot and different version of update system. So imagine that you have like 3 products, 60 variants, 3 different operating systems, 3 different Buildroot, 3 different U-boot, 3 different kernel, and you want even to think how the devices can be in the future maintained. So this was the initial, and it was a bit difficult for me. So, okay, I work with those guys, but all of them upstream something at the end or working together with me for integrated things. So I think I need to recognize some people is here. I think someone is home, but okay. So what is the first point that a company does not use properly, and it is needed as a basic to let a company work efficiently? Understand that a version source control exists. So I mean, and use it properly. Most of the time when you lend to the company, they use the version source control. Is incredible to say, but it's a file sharing. Yeah, it's like incredible. But if you think that they scale up to all the components, then the things are totally crazy. So with the first things I said to them is that we need to adopt a strategy that we can use things in a kind of way that open source community use, and Git is a developer's tools, and not only things that you need to track your change, but you need to work properly with the tools. It's not to having the tools, but then use properly. And after going this direction, because the version control, branching, tagging, whenever you think was totally crazy, then and they accept that things need to be changed. Then, okay, the things can go smooth, and then so we can establish a process. I mean, a process means how can I use what the open source community gives to us in a way that we can establish a correct flow for product management, product release, or building things up. So I use basically all open source components. Yeah, maybe some of you know those components, but I just mentioned Gerrit for code reviewing because it's more a team approach system, and automatic builds. Jenkins as build tool to integrate all release build, verification build, And then what I changed basically is that I convinced the company that upstream contribution to all the projects that we are insist was the best approach to go forward, because we need to in any way to try to maintain in the next years the projects. Why we need to adopt open source, or why we want to? First of all, thank for a lot of companies that help us in this process with other companies is that training. So now a lot of companies start to keep training for a lot of well-known company in open source communities. Some of you know Butlin, Baylibre now. Michael Openacker created root commit for training, Pengutronics. There are a lot, Linar, whatever. So the company that adopts and asks company to be trained start to understand that the usage of open source in the end can be benefits for the company. Even they are pushed a bit from change of regulation. I was in medical, but there is CRA. Then there is the problems, some pressure problems about how much is my operating system secure, how can I reduce maintaining cost, and so on. So, and even you cannot stick what your development flow was 5 or 10 years ago. Everything is changed. And so even, to get to the latest open source, version of your components, it means bring up even the use of the latest tools for use those components. And this one is a term of it is investment, mostly for us, basically, that pay off in the end. I mean, that it will be Nice. So they start from nothing, and after I think a couple of years, they have their process. They have everything, the plannings, the tasks, the testings, and whenever they want. So they started to think that they can now approach the problem in a more structured way. Before it was not possible because you cannot organize any operating system ideas, sprint plannings, or organizations based of not having any substantial things in your company, your organization. And a lot of small or medium companies are in this situation. They create products in a kind of chaotic way. And this, I hope that we change. Of course, for my, for me, for others, make more relaxing. So they even approach and change how the company manage the flow. So they finally able to create their release plan. So the official release and the way to update release, the way to testing, and we talk a bit about it, the production tests and so on. So they start basically for try to have a product mostly stable in the field because it was chaotic, to have a way to update all the products and make a plan for what they want to have in the next release. And then thank you for to change their minds. So it's not always the case that companies completely start from for no process to have a complete process and use open source tools. I appreciate that they get that they follow the idea to change their way to work. And then, of course, this comes from code reviewing, peer reviewing, notification, emails. Okay, they still have some problems. They ask to reduce the number of emails they receive daily from operating system teams, but they accept the fact that they need to review. And some of them review the parts that we send for them inside their Gerrit instance. So what we need to try? So we need to basically try to standardize all the components. What does it mean? We try to move out all the specific change. We try to use the component as they are provided by open source communities. We drop all we try to make all these components to the LTS process, so we follow exactly how the LTS releases are done for the components. Apart U-boot, that we know that we don't have LTS, but the U-boot is a specific component that is even tricky to update on the field, but anyway. So we try to automate, and we automate the testing on the releases. We create, using the fact that we have working on LTS component, we try to have a better CV trackings, and for the vulnerability analysis, and we drop all the vendor lock-in technologies. Yes, and try to learn and continually improve our flow through the open source community, the upstream changes. But what that really means, one of the problems that if you look, if you listen to the talk of Jonah Corbett about Linux kernel and LTS, there is a nice talk about how much you need to be close to the latest kernel, how much patches are different between some LTS to the other one. So it means that we need to accelerate this process. It means that right now we try to, we move the version to 6.6 LTS after some years on 4.19 LTS. And we are already targeting, say, 6.12 and whenever for the next LTS, because we want to reduce, as I said, the surface of things that we need to maintain. And when I work to some board, I found out commit that the vendor does not care about, really don't care about if they drop some legacy interfaces. So if you base your applications on some legacy stuff, then you can get your application that broke because you update the kernel and then the legacy interface just drop. And of course, the vendor does not stick to it to maintain something that he can decide to. So I didn't find funny things that remove complete support from frame buffer for from some kernel, and then I need to to fix up. Yeah, it takes 40 lines of code, but the guy that do the fix, he said, okay, I just drop it, I don't care. So you need really to think about when we adopt any kind of legacy downstream kernel, what can happen. So if we create our ecosystem, our application based on kind of interfaces that are get to be killed, never accepted by the upstream. So and you write a lot of code around it, that is really a problem. So that is the reason that maintain out from legacy. It's make your code more sustainable, more easy to continue to development in the future if you are stick to the upstream or mainline. So, yeah, but as I mentioned, when companies start to write code around some not like standard or accepted technologies, then and you want to migrate all the things around one system, then you need to deal. We deal with different update system for different products. But by the way, it was the same core products, but with different OS. So we need to find out a way to create an OS update package to transition from the old legacy, different legacy. So we need to create like bridge packages to go to some standardized software update. But okay, that way we use the SVU update. We upstream some change to it. Angelo, I think, do it. Angelo Compagnucci for some specific requirements, some specific fix that we need. And then we need to move, all the different Buildroot to one Buildroot and to provide, the same, packages for all the different boards. That is in 8 years ago. I'm sorry to say that I started for 4.70 because it was fast for me. It's, I was working for some other things, and make together things was easy. I mean, that I started the same version that I was playing with the pen drive at the moment. So the system update is always a nightmare. So if you design your own system update, then you said that is the best in the world because nobody covered it, and you solve the things, and then when they said, okay, just show me how to deal with it because I need to migrate to some standard, and then they print me 82 things and they said, okay, whenever I don't want to read it. It's like reading 100 nested if, and the logic is so convoluted that it makes no sense to see it. So we decided to go to don't care it. So just create something that is worth it to make the transitions. And when during the test, we even found that their magic tank was even buggy. So it's, we moving out and we unified all the system updates. Yeah. So what we have now, so we have, everything's the same. So we have Linux mainline and the upstream components for all the boards. We don't, we try to limit now, because at the beginning we have a lot of hardware variants, display, touch control, and sound card. So what we do is to pick all of things and to try to integrate them and to see what was supported, what is not. What was not was upstream, or it's maybe this, okay, but it's a simple sound card, so we upstream. And we try to limit as much as possible the change, at least in the kernel, to the DTS. So, yeah, this is the plans, and people think that when you take a mainline, it will boot, just works. Yeah, of course there is always something to test and to verify that maybe it's not to work as we expected. In fact, we upstream a few things. Okay, the board, it's easy if it's not completed because there are some peripheral that we still work with. Then in the practical, we upstream patches for the touch controller because it was not really properly working in the real hardware and testing. We upstream with Dario canvas patches for IMX28 because even in that area we was having problems. We upstream fixes on end because it was not going to head of 5 mode. It was just going to the minimum speed. And we worked a lot of, I think, times for trying to upstream spectrum patches for IMX families, still on the way. I think that Dario will resend it. And yes, and what the nice when you upstream things on some subsystem is that you find a lot of other subsystems that require attentions, that you have already a view of what is working in other, for instance, CAN bus driver, then we send a lot of things. And then in end, for instance, in the Linux kernel, when we send it, we send then other patches in U-boot. And so this makes fun. I mean, at least in a company like us, developers need to play with the latest technologies and not play with, I don't know, kernel 3.4, whenever. So what is the end up of our experience, at least for the kernel, is that, or the upstream process, of course, we cut the downstream kernel, so we don't care about the downstream. Then we are able now to track and do CV analysis. And so for what is care about vulnerabilities, I know that it is, let's say, talk about bugs in general, not vulnerabilities, because a bug it can be always a vulnerability. So we moved in LTS 6.6, and today they said that the Ethernet controller, the Ethernet does not work properly, but it's okay, there is a problem in the kernel. So yes, and that's what we do. And this way to work is very constructive. I mean, you have a product, you go to some upstream components, you test all the things that you're supposed to work. You find some issues, you send upstream patches. If sometimes you send upstream patches, they send back, you are wrong, you make a mistake, it's not the problems of the kernel, it's your problems, that is fine. But at least you can talk. If you are working with some, some strange kernel, then you cannot talk. I recently have a discussion about Linux real times I upstream, I create all the support for one package in Linux real times. And I was just saying, okay, your board is completely supported by the DTS files. Linux latest mainline, it's just fine, it just support everything. You have the Linux real-time patches integrated. I suggest to play with it. And they said, no, we cannot do. We have NXP kernel of 10 years ago, 2018, is working properly. The Linux real-time patches pass cyclic test, so it's fine. We don't care. Then basically all the hardware testing was done on mainline because they don't have driver for everything, and they need some newer support from the upstream. So sometimes it's really like a decision of the companies what to use it. But I know in this context that I was find a really nice feedback, and so we stay with them for a long time. The Buildroot was even more fun, I think, because all the system was on Buildroot. Everything that was, when you bump some Buildroot version to another versions, and one of the targets of your testing is that the NAND size occupation should not be increased too much, because we have some kind of limited size of the root file system partition. Even now we apply some repartition logic between data, we do BFS, but let's say that so one of our goals when we move to newer version of, for instance, of the Buildroot is to maintain the size as much as we can close. So there is a lot of packages changes, and packages are newer configuration options. Sometimes I say to the developers that you are lucky that you find a bug, or you are lucky that the package changed, because at least you upstream and you change, or you figure out what happened in that packages. So in that area, basically what we do is we upstream a lot of patches, and we even squeeze every time that we upstream patches, we squeeze our patches that are in the external projects. And even more, we then those patches will be thrown away when we get integrated in the official projects. So in this area, so of course patches come. You upload some patches of Zig packages, some GenImage, OpenSSL, the patches that generate 100 patches for the foods factor for apply patches on Buildroot to apply patches. So we found out that apply fuzzy factor 0, then we cause a lot of packages to break because they are really not patching properly. They patch because they are fuzzy patching, but in reality they were not working packages. So when we found that some of our packages was not properly repatched in a new version of Buildroot, then we send these patches, and then we send around 100 patches, I think, to fix all the other packages. Because then when you start something, you want to continue to close it. And it's something great if it's possible. Then our experience on U-boot and NAND and so on let us to continue to improve upload clock driver, upload patches NAND support, because then we're struggling to performance issues, for the booting issues of some platform. So we need to see, okay, why is performing so bad? It was performing good before? No. But okay, but if the requirement is performance good, so we need to take up our experience back and put writing code. It not taking times. I think the clock driver, I was supporting another vendor, and I think that it was written in half a day, and then the review takes more times because the guys that review me was really clever to find a lot of things that I needed to adjust. So I repost a few times, but then was okay. And then let me play with the more speed ups of the NAND controllers. We do a lot of things for bad block handling in the NAND subsystem. So the teams works, really properly in this area because there was really a target for us. So make these products working good and upstream components. So what is our flow? Yeah. Now we basically remove legacy components, make upstream change, try to continue improvements, integrate upstream chains, and go up. So what this bring to us? Yeah, we are able now to continue monitoring security vulnerabilities through tools. Okay, we use open source way to track things, but even commercial tools, I want to say, for that area, but I don't mention them, basically. So then we are able to schedule an update process. So basically, we can, we release one a year or 2 a years, but we want to plan the newest versions during the upcoming months, but we not always, create thinking about to update. There are even features that we added during this process. So the team working basically to maintain it stable and update, even to introduce new feature, because the requirement from a customer, it will change every sprint planning. Then upstream contributions, of course, that is simplify a bit. So now things, how much it costs. That is, okay, we have 100 hours a month, so it cannot cost more than that, yes, and now it's the customer started to contribute to the upstream of the components. In the beginning, we try to make the process and to down our load, because it's very frustrating, works in a very legacy of old code, so it's a balance. So then when they understand that things are getting well, so they like that you upstream your change much more easy. So we push a lot on this year's, beginning of this year's, on LabGrid and automations. We found it nice, quite nice products to integrate in our Jenkins infrastructures. And because one of the problems was not related on the hours that we spend to update components, because we automate most of it. The problem is that how to show that the new components are working properly as the version before. So we need to reduce the times to test. And the only way to reduce the time to test is to create a test that show that the particular things are going well corresponding to the goal. So it means if the file system cannot increase for the next release, okay, you can do offline and not with LabGrid. But for instance, you need to to see if your update process is working as before from one version to other version. So you need to test, update process. You need to test tools that should be installed that you should still have them, because they rely on some file system tool you want to have. They can have different options, and they can want to have that option. So you need to create a test for that one. You need to create a test for the usage of environments, see if your environments that you expect after update are the same environment before the update, if something changed, and everything was, let's say, easy. And not say easy because they are working with, it's quite easy to do it. It's just PyTest by the end. Yeah, so what was completely get is that let's forget about the old approach. So for the new approach, we get what we planned, basically. It takes time, guys. It's not because companies times. So to arrive to Buildroot, stable packagings, kernel LTS, it takes around 2 years. Okay, and now that it's the flow is, let's say, it's approved and they see the way that the things are changing. Now they accept, and they're very happy that we reduce our times to support the platform, because they are planning, or we already have a new architecture to integrate on the same family. So it means that we can, try to reuse times that we don't spend anymore some tasks to support the new architectures. So that is fine. So it means having times to improve and to upstream new change, maybe some other problems on the new architectures. And yes, and then automation. So I think that one of the key points is when you stabilize your flow for creating an operating system, one of the key points is to able easily to test it, at least to cover most of the scenario. So for instance, we have Wi-Fi, USB pen drive that need to support it because it's customer field. So we need to have a switch, we need to have a way to select the Wi-Fi that we want to test, and that should be automated. So the pen drive should be selected. You should select that one, connect to the network, see if you scan the network, if you go to the access point, go back. So this automated testing that most of the time was done in the beginning by them manually, even by us, because we changed the kernel, we need to roughly test everything. Now it's possible to do pretty much automatic. And then the other things that I like more, we work a lot on CV and CV things. There is a lot of work in Yocto, and I'm happy with it. So they really do a great job on this area. But we are on Buildroot, and Buildroot is working. I've seen a lot of patches from Thomas about CV, so it's something. But at that time, so we wanted to have a more, a way to find CV. So the reason that at the end we move to some UI approach, we don't care. So we have basically for an operating system that we release, we have open source, let's say tools, so scripts that go through all the repositories and try to catch up with all the source code that is get patched, which vulnerability they affect, and if they have license violation. So I mean, it's the expected license in the file system are the one that we expect to do. And this allows us to do what is called like risk analysis reports. And we use it to discuss about which vulnerabilities are a priority with other one correspond to the kernel, to the knowledge that we have for that kernel. We even try to change the approach to scan things, to just try to find vulnerabilities that are connected to the products. So we have add some logic. Maybe we should send up, but the product is commercial, so I don't know if it makes sense. And then with that, the nice things that we finally get rid of the way to work in a spaghetti, and we move to standard flow. And okay, and then let's talk about automation, because it's one of the parts that I really like. Because it's it's something that was the missing point in the beginning. Is still so what we wanted to achieve, as I said, we want to have a verification build, for all the things that we patches. So we patches the kernel, we patch its components. We want to see at least at the point of view of working scenario, they still compile and run. And we wanted to automatically doing some testing. So that we try to make all together on Jenkins pipeline. I try now to document in more open source, at least in our wiki, how things should go, how pipeline should be written for getting this. We create even a project for it's a kind of open source meta layer for vulnerability scanning so that is not violating any open source things. It just is open source tools that just use an external tools to send up vulnerabilities, but it's okay. And then we increase, automate testing and integration. So basically, thanks for library at Jenkins and some setups. Now we are we get some hardware from that was supported, and we connect through the exporter or in the library the terminologies are able to control it through the Jenkins node. And so we are able basically to test all the parts that let us spend more times. So it's incredible, but if you think in 1 month, 40% of the time was spent to reply to potential problems on the new version of the operating system. That is quite, it was quite too much. And because it's kind of ping pong, so we wanted to go fast forward and try to merge things up when it's anyways automatically tested. Yes, so the key lesson, but you understand properly that what are is basically we want to work less. But this is the key lesson. So we want really to try to send everything that we found as problems is upstream. If it's a problems, we want to contribute as much as fast as we can. But right now it's basically after patches are in our kernel, we try the next sprint to send upstream to reduce to reduce the times. And and we found out, I think the last point, I mean, I insisted for years, but that is it's matured the times to say that automation is really essential. At least for us, it's really stressful to say, but it's working. Are you sure? You test everything. You test every combination. It was having like a list of tables with a combination of tests with different platforms, different whenever it's difficult. When you automate those parts, then yes, you really can go fast. Okay, I think that I finished my time. No. Grazie. No question. If you have questions, what was the painful? Okay. Yes.
There's sometimes a situation where you're taking a patch upstream that's basically coming from a vendor branch already.
Yeah.
How do you manage that? Do you
Thank you. Thanks for the talk also. I think it was very insightful. You've mentioned a couple of patches that you brought upstream from the IMX6 URL, and I assume that some of the functionality might already have been in some vendor branch from in there. Or have you written those from scratch? Or how do you handle that if you say, okay, there's basically something in a vendor branch and I want to upstream that? Do you contact the original authors, or how do you handle this?
Okay, it's I don't have a lot of times. So when I do the code, it means that my goal is between this morning and this afternoon. For instance, when you ask it, is that no. So vendor, yes, it can be a reference, but most of the time I see that there are areas that the vendor does not, I don't say that doing properly, is that doing it that it works, but it's not really match the design. So for instance, it's still a lot of broken things, let's say this way. But when I start, for instance, let's talk about the NAND part, or the clock driver OLL, there was the clock for IMX-Q, and what I do is this one. I needed to, so my goal was this one. I want to speed up the NAND subsystem of the IMX6 up to the 805 mode of the NAND. I was seeing that the driver, I was already patched the drive for IMX8, I think, whenever it was to go too fast. And then the only blocking issues for the NAND driver for the U-boot was the clock driver. So I said, okay, IMX6Q is supported. The Linux kernel is working, is a good references. The matching between the kernel and the U-boot is they're very close in the semantics, in the way they works. So it does not take weeks, it takes 1 day. So you take the clock tree that you want. Of course, I need to limit the things that is important. I limited my upstreams of the clock part only on the things that I can test. So it's easy to add a new clock when you have the correct infrastructure. So that is take not so much time. But when you solve it, then this magically the driver that it was supposed to have the clock driver connected to the NAND subsystem, then it's open. It's completely, smoothly integrated, and then you can go to between 3 megabytes to 12 megabytes, and then if you have the possibility to have times that I don't have a lot of times, then you just do it, and you don't think too much about it, and that's it's let's say I'm 50 years old now. It's fun. I mean, it's really fun. I don't do it because someone forced me to do it. I just do it because I said, okay, I need to go to that speed. I need by today, or I need in 2 days, so I do it, That is the only way to, I think that a lot of developers are here that do the same. So they like something and they do it. So do it for fun mostly, not for money. The money will come if you do properly.